properties of the six criteria. So some conductor requires at least 50% of the cluster edges. In this case, is a generalization of some conductor criteria where we define of the minimal concentration within cluster edges. The deviation to uniformity is a particular case of this isochronicity where alpha is equal to the global density of edges, the Newman-Gear one, the well-known criterion has a resolution limit, and we don't have isolated nodes. And the deviation to uniformity it's include the within cluster degree distribution is more homogeneous than that found in the Newman-Gear one criterion, and the balanced modularity, which is a regulator between the two previous criteria. So some application. So here we have a real network. It's a network called the Security Karate Club. It's a club of karate of 34 members, so it's 34 nodes. Then node number 1 is the instructor. No, is the administrator. 34 is the instructor. Look at the central position of those nodes. In the real life, the club split because they argued node number 1, the administrator argued with the instructor. So they separated in two clusters in the real life, and in network analysis, we modularized that network in order to see if we can find the two clusters. Those are the results found. So here we have the check. We have each criterion, the number of clusters found with each criterion. And look at the results. 19, some condensate, 7, 6, 4. Okay. Some condensate has 12 single nodes, 3 for obesity and rosy, and 2 for deviation to uniformity. And we found as well that with the one algorithm that the three last, with the three last, we found the same partition. 4 clusters, and the nodes were clustered. The clusters were the same. And here we have a graph of the density of within cluster edges for the 6 criteria. And we can see how the density of within cluster edges for some condensate is very high. Here, for this example, it's more than 0.9. Okay? Whereas the others are manually the same. And here we have the density of within cluster edges of the whole graph. And here we have the partitions form. Look at that. Every color is a cluster. We can see that some similarities between the partitions found. First of all, that all the criteria separate the pink nodes. Most of them separated the green nodes. 2 separated the node number 10. And in the real life, Sakari, when he contracted, when he built this network, he doubted about putting number 10 in the red cluster or in the blue cluster. And 12 as well is separated by these both criteria. Here we have the next example, which is a network of musicians, of jazz musicians. We have n equal to 1 hit nodes. Here I described the partition form with 3 criteria. Newman-Gear 1 balance, modularity, and deviation to one determination. The first column of each table is the size of each network. The second is the average degree, the standard deviation, and the coefficient of variation. So we can see as well that the two new criteria found more communities than the new Engelmann modularity, and that they have nodes clustered with a single nodes here. So these two criteria, they tend to separate those nodes which have low degree. And now, let's look at the graph. Here, I represented the coefficient of variation for the three criteria for the degree distribution. So, look at this. For the deviation to undetermination, we can see that the degree distribution is more homogeneous because there is less variation. Whereas with the new Engelmann modularity, we have nearly the same as the balanced modularity. So I finished with that. So the conclusion, we presented 6 modularization criteria in relational analysis notation, and we tried to analyze the partition formed with those criteria, to analyze the differences. We saw as well that, however, they have nearly the same properties. They vary dependent on the degree distribution, the sizes of the networks, the global density, and finally we can see that there is, in some cases, we find more homogeneity or heterogeneity in the degree distribution.